Today our class is about dielectric materials. The course outcome of this dielectric materials is usage of this material for engineering applications. So let us discuss about this dielectric. These are the materials having electric dipole moment permanently. Main concept of this lesson is formation of dipole. Without positive and negative charges, the material is said to be non-polar materials. If we separate positive charge and negative charge, then the material is said to be the polar material. Dipole momentum is product of charge and the distance. Here plus q is positive charge and minus q is the negative charge. X is the distance between the two charges. Then dipole momentum is product of charge into distance. All dielectrics are insulators and they are manually used to store the electrical energy. All dielectrics are electrical insulators and they are mainly used to store the electrical energy. Examples of dielectric materials are mica, glass, plastic, water and the polar molecules. This is the picture of the dipole, plus charge, minus charge, electric field, and this is the dielectric atom. So this is example of the capacitor parallel plates, and separation of positive and negative at certain distance is called as the dipole. This is about dielectric constant, one of the important property which explains relation between medium permittivity and the vacuum permittivity. Medium is epsilon, vacuum is epsilon naught, and epsilon r is the relative permittivity. It is one of the characteristic of dielectric material. This has no units. We get this property only if the flux transmits from positive charge to the negative charge. Epsilon r is also known as the dielectric constant. Epsilon r is relative permittivity. Another name is dielectric constant, and it is permittivity of the free space, that is said to be the vacuum. So most important concepts of our present lesson is about polarization. Polarization means formation of a dipole. We consider all materials, originally they are neutral because at the center nucleus is there. Around the nucleus, positive charge nucleus, around positive charge nucleus, electrons are revolving. So due to combination of plus and minus, the concept is a neutral. If you place that material inside the electric field, then positive and negative charges will be get displaced. So this concept is called as the dipole formation, and this is known as polarization. So we can polarize atoms, we can polarize ions, and we can polarize molecules. So all these concepts are discussed here. The main overview of the lesson is about discussing the types of polarization. Now we are saying about electric polarization. The process of producing electric dipoles by the electric field is called polarization in dielectrics. And phenomena, that is polarizability. Induced dipole moment per unit electric field is called polarizability. Here inducing means transferring the charge without touch of the material. So any material can be get polarized by application of electric field that is applied to the normal materials, but for dielectric materials we need very large quantity of the electric field. So suppose for example, if you take dielectric materials for electrical appliances, if there is dielectric loss, then current will transmit to the material. Induced dipole moment is proportional to the intensity of the electric field. Here intensity is the strength of electric field. That is what I explained. Dielectric materials depends on strength of the electric field. So first input of our lesson is field, that is electric field. Can anyone get a doubt? Can we induce dipoles with the help of magnetic field? No, we can't. We can induce the dipoles only by placing the material in the electric field. Electric field induce electric dipoles and magnetic field will indicate magnetic dipoles. This is the difference between electricity and magnetism. Now let us see the formula. Mu proportional to E. Here mu is dipole, that means plus and minus at separation of certain place, and E is the electric applied field. Without field no dipoles, then it indicates mu is equal to alpha E. That means we get material polarized only when we place the material in the electric field. Without field we can't get the dipole, so that's why alpha is the polarizability constant. Next, the dipole moment per unit volume is the polarization vector. So we are considering the volume of the dipole material also. So here V is the volume. Per unit volume we will get the dipole momentum. It indicates certain direction, that's why it is a vector quantity. Electric flux density. Flux means force lines that always transmit only from positive charge to negative charge. They can't transmit from negative charge to the positive charge because force lines transmit only from high potential to low potential. Always positive charge is at high potential and negative charge is of low potential. That's why always force lines transmit from positive charge to the negative charge. So group of force lines is called a flux. If we consider group of electric force lines, that is electric flux. If we consider the group of magnetic force lines, then that is called as the magnetic flux. Present lesson is about electric flux. How much strength of electric flux is there, that is called electric flux density, denoted by D. This is 0 if there is no electric field. If there is no electric field, then mu, dipole momentum, is 0. Then electric flux density D, this is also 0. Nothing exists in our present lesson without electric field. So without electric field there is no lesson. If there is electric field, that is our entire lesson. So our present lesson explains that if a material is placed in electric field, what are the changes occurring in our present material. So we learn what are the differences without electric field and with electric field. Electric field makes up a new chapter in engineering physics. Try to understand this. So electric flux density is defined as it is a charge per certain area of a material. Always in physics we consider the dimension of a material, how much place the charge exists, and it has same units as the dielectric polarization. Electric flux density at a point in the free space is of electric field strength. So if there is a low field strength, then electricity can't transmit through the material. If there is high field strength, then only electricity will be transmitted. Suppose if the metal is in medium, then we get all denotions original. If the metal is in the vacuum, then we get the denotions as d naught, epsilon naught. If the metal is in medium, epsilon. If we consider vacuum, epsilon naught. Then d also. Metal is in medium, d. If the metal is in the vacuum, then that is said to be the d naught. So in vacuum we get additional polarization. So our formula becomes d is equal to epsilon naught e plus p. P is additional polarization. At the same point in a medium, this is given by d is equal to epsilon e, indicates material is in medium, and d indicates positive and negative charges are separated by placing the material in the electric field. So this indicates that dielectric displacement measures the material additional polarization when the material is in vacuum. Another name for vacuum is the free space. Next, polarization measures additional flux density when the material is in the free space. So our present lesson explains about properties of dielectric materials when the material is in medium and also when the material is in the vacuum. So epsilon, permittivity in the medium, capital E, electric field, that is equal to epsilon naught E plus P. If there is no P in the first formula, this indicates material has equal amount of polarization when placed in medium and placed in vacuum. But the first formula indicates material gets additional polarization when it is placed in the vacuum. Simplify this formula, we get epsilon r minus 1. Here we got epsilon r. Here epsilon r is the relative permittivity which relates both the material medium permittivity and the material vacuum permittivity. Electric susceptibility denoted by Xi. This is one of the most important property of dielectric materials which gives ratio of polarizability to applied electric field. Here Xi is electric susceptibility. We get this in magnetism also. That's why we are saying Xi. E means electricity. Xi m means magnetic susceptibility. Polarization vector P is vector because it shows the direction also, in which prescribed direction electric flux flows. It is proportional to the total electric flux density. Total electric flux means how much magnetic lines or how much electrical lines which transmit from positive charge to the negative charge. If we consider magnetism, that is magnetic flux density. In electricity, that is electric flux density and the direction of the electric field. Therefore, the polarization vector can be written as P is equal to epsilon naught Xi. Here epsilon naught is the vacuum permittivity. Xi is the electric susceptibility. Epsilon naught is vacuum. Metal is in vacuum. Epsilon r is we are relating the medium and the vacuum concepts. Xi is epsilon r minus 1. This indicates relation between electric susceptibility and epsilon r. This indicates the term is relating both. Epsilon r indicates the difference between material placed in medium and also material placed in the vacuum. Polarization, formation of dipoles. Our entire lesson is about dipoles, polarization, and types of materials and types of mediums. This is the overview of our present lesson. It is similar to the electricity concepts, but electricity explains about conductors and insulators, but our lesson is about insulator concepts. So in electricity, conductors are not only important, insulators are also important. That is the prominence of our lesson. So first, our lesson, materials. There are two types of materials: electric materials, polar materials, and non-polar materials. In polar materials, there is no electric field. Positive and negative charge are in combined position, so plus and minus gets cancelled, so material is in neutral. But in polar materials, positive and negative charges are get displaced. Due to that, material becomes polar material. Next one, which material can be get polarized? We can polarize atoms. This is called electronic polarization. We can polarize ions by placing in electric field. Ionic polarization. We can polarize molecules, so that is called orientation polarization. We can polarize the ions in the free space, that is called as the space charge polarization. We learn entire briefly about all these four types of polarizations. The same amount of electric field should be applied. No, there exists difference in the magnitudes of the electric field to be discussed in these polarizations. So entire description of these various polarizations will be continued in the next physics class.